Don't you want me, baby? Hmm. Don't you want me, baby? Oh my God, all these invites. All these emails. All right, so I'm talking to this guy. Friday at noon. We're gonna do a quick stream today. We got 45 minutes. Mhm. A quick stream, a quick one. Let's let me fix this. Hold on. I think probably there. There we go. Okay, we'll update that. A quick stream. Oh man. Ugh. There's some interesting things going on. What are we talking about today? What's been new? We got Meta and Manus. I think that's what we'll talk about a little bit. Talk about Meta and Man. This is interesting. Work trunk. A Git work tree manager. Interesting. Let's see. Show me the repo. Dev of work trunk. By day, quant, prev CIO 60 capital. Yeah, there's a problem with this though. There is a problem. There is a problem. There is a problem. Hmm. This guy. Co-creator of Django. Interesting. So there's a problem with Git work trees that we don't talk about. So I just saw this, right? Announcing work trunk, a Git work tree manager designed for running AI agents in parallel. I'm working on something similar, but there's a problem with the way that Git work trees today. So the way that Git work trees work, it's actually really simple. You basically make a copy of the working directory into a new directory. It's just like it's a wrapper effectively for like a move command or a copy command of the existing work tree. And then you have an agent that can work on that. But there's let's talk about some of the downsides to it. I actually just tweeted about this recently. Let's see, can we see this? Okay, yeah. So imagine you have a Git work tree. Let's talk about this for a second. So you have like this is Git, right? This is Git. Let's make this a little bigger. There we go. Actually, let's make this a little bit smaller. Okay, so this is your like working, let's call it your CWD, right? Your current working directory. So when you do like git work tree, like git work tree, what that does is that it creates a full copy of your current working directory here. Let's do some arrows. Boom, boom. This is one way. Nope, I want that. Uh, I guess this is technically this way because so this is a copy command. This is like pseudocode, right? This is copy command. Um, and then it essentially pastes it, like paste command, right, into a new working directory here. So what this ends up looking like is, imagine you have like, repo, tab, and then you have like I don't know, called source like this, and then in here you have like a main dot. I'm just gonna do Rust because I've been doing a lot of Rust lately. So when you couldn't do get work tree, essentially just does let me see, goes here, and then it does like work tree src, and then it does main.rs. But there's a problem to this, right? The way the way that it does this is that because it copies the entire current working directory, that means it also copies over all the dependencies, right? So if you have, for example, like a whole bunch of node modules, or if you're in Python and you're dealing with like gross, Python environment nonsense. Let's say you have another one here, right? Here, and then we're gonna like, let's say you get work tree this one too. Whoa. Like that. This is ugly, but you know what I mean, right? And then like here, let's say you have like, this is you working, you. But then you go to, this is like, agent one working on the like auth branch or whatever. And then this is like agent two working on the like bug branch. So if you have a bunch of gross node modules here, can we flip this? I never, when you flip stuff like this, I never know which way that you're supposed to flip it. Like, do you flip it this way? I think so, right? So like, let's say these are node modules. When you do this get work tree thing, you're copying over your node modules every time, right? So all of a sudden your repo just like ballooned, right? Because you now have, this is not good. Oh, okay, let's do this. Source, and then you have like, node modules or whatever. And now you have node modules here too, right? That presents some problems. Who can think of, like, what is the main problem that you're going to run into here? When you do a new git work tree, you're copying over the entire current working directory, including all the dependencies. What is the problem? This can get really heavy, right? This can get really, really heavy. So all of a sudden, you now have, if you have a ton of node modules, right? When you get into any like sufficiently big repo and you have, especially if you're in a mono repo, like we used to work with a lot of mono repos, these things get really big. Like you're talking about thousands and thousands of files, right? These aren't just like 50 files you're working with, right? These can be hundreds, 1,000 node modules, depending on how big it is, right? It can be huge. And so if you're copying over that entire working directory every time you spin up a new agent, first of all, it's slow, right? Because you're having to make this full copy. And then you have to write it atomically to the file system. But then you also get, somebody mentioned, parallel lock files. That's what we'll talk about, parallel lock files, right? But even in some ways, even more basic than that. The issue that you get is you have this merge problem because all of a sudden, hold on, where'd this go? If all of a sudden I need to add another node module here, right? Let's say I need to add in, this is like, I don't know, whatever, like dep1 or whatever. I know I got distracted. Sorry, I got distracted. This is gonna be a quick stream because I have a call at 7:30 in 40 minutes. So we'll pick it up tomorrow. Again. So my point is, right, if you had another dependency here, right? And like let's say you do another dependency here, this is like dependency like 2 or whatever. This gets ugly because now you're having to manage n number of work tree merges, all of which may use different dependencies. That's pretty gross. That's pretty ugly, right? So how do we build a better Git work tree? Because I think what's interesting about what this guy did, where is it here? Like this is cool, right? This is like, it's a cool little like maybe UI, and like, I'm building something that will look a little bit better than this, hopefully. But that's not really the point, right? The point is like, it's actually just fundamentally a file system problem. Like You can put a new wrapper around Git work trees and have a little like TUI on it and it looks nice or whatever. But that you're not solving the fundamental problem, which is it is a heavy write operation every single time that you want to add on a new work tree. Because nowadays you have people who are doing like, man, they're doing like, you know, 4, 5, 6 agents at a time. So imagine having 6 different concurrent copies of your working directory being worked on by different agents. And then trying to manage the merge across all of that, bro, that is heinously painful, right? So one way to do this, right, if you're going to think about this from the beginning, if you said, hey, I'm going to think about this from first principles, like put Git aside, what is the right way to build this? So one thing you could do is you could have your current working directory, like let's just take this here. We'll just do this real fast. All right, let's just say you have your current working directory. This is going to be, in a first principles world. How do you spell first principles world? All right, one thing you could do is you take some inspiration from the database world, right? You do a copy on write. What is copy on write? Do we know what copy on write is? Copy on write. Neon is, the Neon, the database company. They're pretty popular for this, right? Neon DB copy. This is their whole thing. This is how they do their instant branching, is copy on write. Let me see if I can find a good explainer for it. I want to find a good image. Yeah, this is all Neon stuff. So DB copy on write. Let's see. Why did they make this? I feel like they should have an easier way to explain this. Maybe let's look at good old wiki. Implicit sharing or shadowing, right? It's a resource management technique because the idea is that instead of having and creating, for example, a brand new working directory, you're actually just you're using almost like a view of the existing working directory, right? It's a way to manage data across different sort of different, I'm going to say file systems, but different data structures really. It's not really just a file system. So when multiple programs use the same set of data, so instead of copying data right away, the same data is shared across multiple problems until one tries to modify it. If no changes are made, no private copy is created. A copy is only made when needed, ensuring each program has its own version when modifications occur. So we can do this within our little work tree scenario to say, okay, well, what if we just create kind of a view of this current working directory? Right? We're gonna have the general principle here, which is never break user space. This is like, Linux, Linus, actually even better, Linus. Never break user space, never break user space. So if you create, for example, a zero copy clone here, and really it's just like I said, right, it's just a view. This becomes super fast. So instead of having to copy like the entire working directory over, you can actually just create effectively a view of your existing working directory, which is an isolated only to you. You create a copy of that, and then now I'm gonna create like a bunch of these for a sec. And then now you can share dependencies across those, and when they need it, right, when each individual agent, so these are going to be agents, agent 1, agent 2, agent 3, when they want to make changes to the node modules, because for example, one branch needs to implement a new dependency or whatever, it gets copy on wrote. Is that how you say it? It gets copy on write it. That's what I'm gonna say. Because it becomes a lot nicer, right? Because then you can say, okay, look, we're gonna have a base set of all the node modules that all our dependencies that everybody's going to have access to because everybody is starting from the same base point, right? We know everybody needs all of these. You may add on more, which is fine, but it doesn't make sense for us to copy these. So instead, we're just going to take this and put it right here. Now everybody gets access to the same base set of dependencies. And then each individual branch has the ability to add on more dependencies if they want. Now all of a sudden, you're able to create a lot of these work trees a lot faster, right? Because you're sharing shared resources, and you're never breaking this like really nice user space, which today it does. The other thing you'd want to add on here too is like sandboxes are going to be a pretty big thing right now. They're starting to become pretty popular. This is just file system isolation. There's no process isolation. So as soon as you want to start doing any sort of like commands, like if these agents want to run commands, that's when you get into like, okay, do we want to isolate the process itself? That was obviously what like Docker was invented for, is like you have this nice container, this nice isolation of process and file system and memory and resources. Should agents have the same thing? The answer is like, I think yes. Because if this agent does something stupid and it runs some like, dumb like remove, like, this thing remove rf, dot slash like an idiot, you don't want that to mess up this guy here. Like this is your immutable base copy that everything else is built off of. This is user space. We're not going to touch this. This agent does that. You want this to be in its own little like process isolation, and it shouldn't impact anything else. So sandboxes are going to be big. They're actually pretty interesting. Um, so how did we get here? We got here because we saw this new Git work tree manager. The thing I like about this, and the thing that's missing from today from Git work trees, is like just the nice orchestration around it, right? Like today, if you want to do Git work trees, you have to like CD into every subdirectory, aka every work tree to check it out, which is like kind of kind of slow and boring. There should be a better first class way to do this. So I think this is pretty cool. I like seeing stuff like this. I think I'm excited to share what I'm working on when I'm ready for it. But okay, should we talk about Manus? Manus and Meta acquisition? Guys, we got 30 minutes. We have 30 minutes. Meta to buy Manus, an AI startup with Chinese roots. So I don't think it was announced how much they paid for it. From what I've seen on Twitter, it looks like, yeah, like around 2 billion was what they were paying for it. So Manus last reported, I think it was 150 or 125 million of ARR. Um, that was recently. I want to say like in the last like couple of weeks, maybe in the last month. Why do they keep suspending me? Repeated violations of community guidelines. I wonder why it keeps happening. I'm showing a Wall Street Journal article. I think I might just have to stop using Streamlabs. I think we might just have to stop doing it. I'm gonna angrily tweet at them. Like, how annoying is that?